Okay, so I'm going to tell you about matter and radiation. So just simple concepts, so some background about electrons, protons, nucleus, so all these things, so you can then use it for the actual particle physics, okay? So first we are going to go on the structure of the atom. So that's how the atom looks like. So we have the nucleus right at the center, and we have the electrons going around more or less in shells, but they actually don't go around into nice circles as we learned in the past, okay? And just for you to have an idea, the nucleus, although is very massive, as you will see in a second as well, if this was the whole stadium, so imagine just a stadium, the nucleus is going to be a small bean in the center of that stadium, okay? And it's despite the fact that it's so small, it still contains most of the mass of the whole atom, okay? There's going to be a new keyword for us as well, which is nucleon, okay? And when you talk about nucleons, or when you hear about nucleons, they simply just say that is a proton or neutron in the nucleus. So I can refer to them as nucleons, okay? So, this is a table that relates the charge and the mass of the proton, neutron, and electron. So all of them are in the atom. And there are three conclusions we can take from this table. But before I go on the conclusions, let me just tell you that the electrons, they do have a negative charge, and they are held in the atom because of a force which is called the electrostatic force, okay? So it's a force of attraction between them and the nucleus. And the nucleus has a positive charge overall because it has neutrons with zero charge and protons with a positive charge, okay? So if you look at this table, and of course you can take notes of this, you can see three things, okay? They are very important. Number one is the electron has a much smaller mass than the proton or the neutron. So if you go here on the mass in kilograms, you can see the electron has a mass on the power of minus 31, 10 to the power of minus 31, while the proton and the neutron, they basically have to the power of minus 27. The proton and the neutron, they have almost equal mass, so you can see just on this table we can just consider them to be the same. And finally, the electron has an equal and an opposite charge to the proton, to where you can see in here, okay? So neutron, no charge. And then the charge that comes in coulombs, by the way. In a proton, we have a positive 1.60 times 10 to the power of minus 19. And for the electron, we have a negative minus 1.6 times 10 to the power of minus 19, okay? One more thing for you, so some more keywords. Number one, we need to talk, we need to talk about atomic numbers, okay? You already know this from GCSE, but the atomic number, which we refer as the letter Z, is the number of protons in an atom. And if I ask you to look here in this picture, you can see that this is my chemical element, and Z is right here under the chemical symbol, which is the number of protons, okay? So the atomic number. Then a new one for you, Nucleon number or mass number, which is A. So it's going to be the total number of protons and neutrons in an atom, which is the number that is almost numerically equal to the mass of the atom, okay, in terms of relative units. And we consider the mass of the proton to be 1, so we use that as the term of comparison per se, okay? And again, if we look here in the picture, here on the bottom, you can see electrical symbol and then A, the number of protons and neutrons together, or nucleon number, is showing right here on the top above the chemical symbol. We need to know about isotopes as well, and isotopes are atoms with the same atomic number but different mass numbers, okay? So they have the same number of protons, so the Z number is the same, but they have different number of neutrons, okay? So the number of protons and neutrons, right here the A, nucleon number or mass number, is different, okay? And finally, the nuclide. So that's going to be a type of nucleus with a particular number of protons and neutrons, okay? So for example here, I have this nuclide, and then I have here my uranium symbol, 92 as the Z, so the atomic number, so it means that I have 92 protons, and 338 as the nucleon number or the mass number, so my A, okay? So that means that I have a total of of protons and neutrons, sorry, to be 238. And as they say in here, it has 92 protons and 146 neutrons, okay? And I get this number by doing 238, the number of the protons and the neutrons, minus 92, the number of protons, and therefore I get that the number of neutrons is 146. One more thing that you need to know, which my keyboard didn't work now, or no? Okay, it's working now. So remember, by the way, I think I didn't have to tell you this, but remember that when I'm talking about atoms, they do not have a charge. But if I talk about ions, then they have a charge. They can be positive or negative, okay? So they either lost or gain electrons. New things that we need to know. We need to know about this thing called specific charge, okay? And the specific charge is when I talk about the particle's charge divided by the mass, okay? So I simply need to pick the charge, taking in consideration the number of electrons, protons I have in there, and divided by the mass, so taking in consideration everything that makes up that particular particle, okay? So for example, and you can try this, you can pause the video and try, you can calculate the specific charge of the electron, which has 1 as the mass number and 1 as the atomic number, okay? I want the hydrogen nucleus. The electron, okay, which I already mentioned, and then finally the ion of magnesium, okay? And the ion of magnesium is something where there is a difference of 2 electrons, okay? And I have here the mass number again showing as 24 and the atomic number here showing as 12, okay? You have some data here that you can use, okay, to try, and I'm already telling you that the ion of magnesium, the charge is going to be plus 3.2 times 10, this E equals times 10 to the power of minus 19, so that means that the magnesium loses 2 electrons, so it has a 2 plus as charge, okay? So give it a go, try the exercises, and you will know that you have them right if your answers are, for number 1, 9.58 times 10 to the power of 7, and then units are coulomb charge divided by kilograms, which is mass, okay? For number 2, the answer would be 1.76 times 10 to the power of 11, again, coulomb per kilogram. You always need to state the units. And finally, for the ion of magnesium, you would have 8.04 times 10 to the power of 6, and again coulomb, which would be a big C in there, divided by kilogram, okay? So that's all that you need to know for now. I just dropped the microphone. That's all that you need to know for now, and I'll see you later. Bye. And let me just stop recording.